Okay, now on to chapter 22, the last video for today, where we're comparing two groups, two samples on a percent. So first we're going to do hypothesis testing. Is there a difference between these two groups in the percent that have some characteristic? And then we'll do a confidence interval. How big is the difference in percents? So our example for this one is Joseph Lister of Listerine fame was a physician who wanted to see if germs were the cause of infections. In 40 amputations, he used carbolic acid to disinfect the operating room, and 34 patients lived. In 35 amputations without carbolic acid, 19 patients lived. So our question, our yes-no question is, did a significantly higher percent of patients live when carbolic acid was used as a disinfectant? So let's think about our 4 questions to figure out what formula we need. Well, what kind of data have we got? Did the patient live or die, right? Categorical. 2, do we need sample size? Nope. In fact, we've got 2 of them. We've got 40 patients where carbolic acid was used to disinfect the operating room, and 35 patients where carbolic acid was not used. So we do not need sample size. We've got 2 of them. Number of samples, 2, with and without carbolic acid. And then finally, confidence interval or hypothesis testing, we're asking a yes-no question. Did a significantly higher percent of patients live when carbolic acid was used? So we want hypothesis testing. We're going to answer a yes-no question. So we need that 4-step procedure again. Hypotheses, test statistic. The test statistic is always comparing our sample to our null hypothesis. How close is our sample to what we claimed? A big test statistic means our sample is a long way from what we claimed, and a small test statistic means our sample is close to what we claimed. So now we have 2 groups, and we're dealing with percents. So the null is always no difference, nothing going on. So our null is that there's no difference in the percent of patients that survived, whether or not carbolic acid was used. And now we wonder if a significantly higher percent of patients live when carbolic acid is used. So here's the carbolic acid group. We wonder if the percent that survived is greater than the percent that survived when carbolic acid was not used. So the null is always equal to, and then the alternate is something different than that. In this case, we wonder if the percent that survived here is higher than here. Now the test statistic for this one is a mess, so I am never going to ask you to do that. So I'll just always give that to you. So Z is 2 point from the StatCrunch output, and the p-value from the StatCrunch output is 0.0018. But we could have easily gone to table Z and figured that out. We're wondering about greater than. So we would just go to table Z and figure out the percent greater than 2.92. 2.92. If we go to 2.92, the percent greater than that is 1 minus 0.9982 or 0.0018. So StatCrunch gave it to us, but it would have been easy to find in table Z. Finally, our decision. Well, if alpha was 0.01, how does this compare? It's less than or equal to that. If alpha is 0.05, well, if it's less than 0.01, it has to be less than 0.05. And also it has to be less than or equal to 0.10. So for all 3 of these levels of alpha, we would reject the null. We would have statistically significant results. And we would answer the question, yes, the percent that survived after disinfecting the operating room is higher than the percent that survived if you did not disinfect the operating room. So yes, a significantly higher percent of patients live when carbolic acid is used. What would the alternate be if we wondered if the percent alive differed between the 2 groups? Well, if we just simply wondered if the percent was different, we would change it to not equal to. these survival rates are the same versus these survival rates are not the same. They're different from each other. And what would the new p-value be? Well, if we have a two-sided alternate hypothesis, we have to take into account this, and our new p-value would be 0.0036. It would be doubled. And at what alpha would that p-value be statistically significant? Well, this 0.0036 is less than 0.01, less than 0.05, less than 0.10, so it would be significant at all three alpha levels, just like the one-sided p-value was. That's hypothesis testing, when we've got two samples compared on a percent. And then confidence intervals. How big is the difference in survival rates? How big is the difference in survival rates between using and not using carbolic acid with 95% confidence? Well, now if we want to know how big it is, what is the range in which we expect to find that difference, we need a confidence interval. So if we think about our questions, we're dealing with percents, the percent that lived. We've got two groups, with and without carbolic acid, and we want to know the size of this thing. How big is the difference? So we would use a confidence interval. So we would go to our yellow formula sheet. We're dealing with percents. We have two groups, carbolic, no carbolic acid. We want a confidence interval. So there's our formula right there. Where P1 and P2, our sample percents, are tweaked a little bit. We have the +4 for these confidence intervals for percents. And now we're adding 4 total, 2 to each group. So we add 1 to the top and 2 to the bottom for each group. So our formula is the difference in sample percents. We always start with our sample information times Z and then the second group so we just need to find those numbers. So the first sample percent with carbolic acid, we had, let's see how many who survived. We had 34 out of 40 survived, but we're going to tweak it, add 1 to the top and 2 to the bottom, and that is 0.8333. So about 83% of the patients survived when carbolic acid was used to disinfect. The sample percent when there's no carbolic acid was 19 out of 35. Add 1 to the top and 2 to the bottom, and we get only 54% survived. And Z, if we want 95% confidence, is 1.96. So we'd fill all these things in, punch it all in our calculators, and we would end up with a confidence interval of 0.097 to 0.489. So I wrote out the formula, and I wrote out the numbers, and I also gave you StatCrunch output. So there's the confidence interval right there. So now we have a few questions. How do we need to interpret that confidence interval? I give you four options. First, I am 95% confident that the percent alive in the population of amputees is 9.7 to 48.9% higher when carbolic acid is used than when it isn't. Well, remember, when we look at a confidence interval for difference, the first thing we're looking at is the signs. In this case, we have two positives. So the difference, the percent when carbolic acid used minus the percent when no carbolic acid is used, is greater than 0. The difference is positive, but then the percent who survive when carbolic acid is used is greater than the percent that survived when there was no carbolic acid used. And how much greater? These numbers give us the size of the difference. So number 1 is correct. Number 1 is correct, that the percent who survived with carbolic acid is greater than that survived without. How much greater? 9.7 to 48.9%. The next one is not correct because it did it backwards. It said that the survival rate was better when carbolic acid was not used. So if this had been a negative and a negative, then we would have concluded that no carbolic acid did better than carbolic acid in survival rates. The next one is incorrect because it says there is no statistically significant difference. That would be true if we had a negative to a positive. So 0 was in the interval. If 0 was in the interval, the difference might well be 0, and so we say there is no difference in the percents. And finally, the last one is incorrect. I am 95% confident that 9.7% of the carbolic group lived and 48.9% of the non-carbolic acid group lived. That's wrong on 2 counts. One is talking about samples. That's not right. And second, this is a confidence interval for the difference. We know the percent of carbolic acid patients that survived, 83%, and we know the percent of no carbolic acid patients that survived, 54%. So those are the sample percents. This is the confidence interval for the difference in sample percents. So the problem with 4 is that it's claiming that this is 1% and this is the other. No, this is a confidence interval for the difference. That's it. I'll see you tomorrow.